In this video, we're going to cover some factoring of trinomials where the a value, the leading coefficient, is not equal to 1. There's going to be a 2 in front, a 12 in front, and a 5 in front. I'll go through the steps of factoring by grouping as well as factoring using the box method to get the job done. But before we get started, I'm going to actually give you the answers to the trinomials. So these are the factored form of the trinomials, and I'm going to distribute them with arrows. I'm going to also show you the box method to see how you would check your answer. So you've got your factored form, you go back, distribute everything, compare it to the original trinomial, and see if your answer matches what you had started with. And hopefully you could actually draw some comparisons to the work with factor by grouping, which we're about to do, as well as the box method that we're going to also do as well. In our first problem, we have 2x squared plus 13x plus 20. And normally we could look directly at this c value and figure out the two factors of 20 that also add up to be 13, but we can't do that now because our a value in the middle is not equal to 1. It's a 2. So we have to do something a little bit differently. And to begin, we're going to take 2, the leading coefficient, and multiply it by 20. 2 times 20 is going to be 40. And then we got to come up with all the factors of 40 and figure out which pair also add up to be 13 in the middle. So you could start with 1 times 40. Of course, that's not going to add up to be 13. 2 times 20, that's not going to work. But if you go all the way down and do 8 times 5 is 40, and they also add up to be 13. So what we're going to do next, now that we know that these two numbers are the ones that we want to go with, we bring down 2x squared, and then I plug those two in with x. So I'll do 8x and then plus 5x, and then I bring down the 20 plus 20, and we're going to group them. So I'm going to put these in parentheses and then these two in parentheses, and I'm going to figure out the GCF of this first binomial, I guess these two terms. So the GCF here is going to be a 2 and an x. We could factor that. And then if we divide out that 2x, we'd be left with an x plus 4. So 2 divided by 2 is going to be 1. And if we take out an x, we're just left with an x. If we take 8 divided by 2, we're left with 4. And then we also divide out that x. And then over here, right, 5x plus 20, we also have a GCF that we could factor out. That's going to be a positive 5. And then when we divide out both of these terms by a 5, we're going to be left with just x plus 4. And that should be the same as this one. So these two should be the same. And then you've got your factors right there. You got your 2x, 2x, and then that plus 5. Just whatever you factored out, your two GCFs, you'd put as your first binomial, and then that binomial that was in parentheses, that should be the same if you do it correctly, is going to be x plus 4. So that's going to be your answer. Now, you could also do it with the box method. If you want to put a box just like this, and every single time I know I'm going to have an x here and an x here, I'm also going to have to put in my leading term, my ax squared term there, and my constant goes down there. And then you could do the same process. You would take 2 times 20, which would be 40, and then you come up with all the factors of 40 like we did right here. We'd realize that 8 and 5 were the two that we wanted, so we'll plug in 8x and then also a 5x. And then you would do the GCF going out this way and this way, the two rows. So in this case, it was just the x, 2 and 5, the GCF would be 1, so we don't have to write that here. Down in this bottom row, 8x and 20, the GCF is going to be 4. So I could put a plus 4 there. And then we'd also want to find the GCF going up in the columns. So we could take out a 2 between 2 and 8. That's going to be the greatest common factor. We also have that x. And then going straight up here is going to be a 5. So that's a plus 5, so positive 5. And that's going to be the same answer as what we had here. The 2x plus 5 you've got right there is the 2x plus 5. And then we also have the other one here, that x plus 4, and I'll add that in. Okay. Let's do another one. All right, so once again, our A term right here is 12. It's not 1, so we're going to have to do something a little bit different. We're going to take 12 and multiply it by 3. So that's going to give us 36. And we got to come up with all the factors of 36, figure out which two add up to be a negative 13. So I'll go through and start with 1 and 36. So 1 times 36 is 36, but we have to have them add up to be a negative number in the middle now because that's subtraction. So we got to make sure all of our numbers there, the factors that we come up with, are going to be negative. So you keep going and find all these different combinations of factors, but we're going to eventually get to negative 9 and negative 4. And those are the two that add up to be that middle term, negative 13. So what I can do is bring down my 12x squared again, and then write in a negative 9x as well as the negative 4x, and then I bring down my plus 3. And I'm going to group them. So I'm going to put parentheses around the two pairs there, and then I factor out my GCF again. I go GCF going out this way and a GCF going out that way. So the GCF that we're going to take out is a 3 as well as an x. And then 12 divided by 3 would be 4. If I take out an x, I'm left with an x from the x squared. And then negative 9 divided by 3 is going to be minus 3. And if we're taking out an x, that goes away. We're just left with that minus 3 there. And now we do the same thing here, except that leading term, as you can see, that negative 4, if it's negative, you want to divide out that negative 2. So treat that GCF as negative. So it's going to be minus, and then the number that we would divide out, the GCF, is actually just going to be 1 because there's no common factor between 4 and 3 that is bigger than 1. So I'll just put in a minus 1 there, and then in parentheses, negative 4 divided by negative 1 is going to be a positive 4x, and then positive 3 divided by a negative 1 is going to be a negative 3, or we'll put down minus 3. And again, we know that we're doing it right because these two in parentheses are the same. So then I'm going to take my 3x and then my minus 1. That came from the beginning there and right there. And then I followed it up with my common binomial, which was 4x minus 3. And I'll show in the box method again if you just preferred that. So I'll put down my box method, or my box. I'll add in my first term, my ax squared term in the top left corner, my c term in the bottom right hand corner, and then the two numbers that eventually you would pick would be that negative 9, throwing in x's with it too, that negative 4x, and then we could go about the GCF for the rows, and there's always going to be an x here because usually there's going to be x and an x, so I get to take out an x as well as a 4. That's going to be the GCF there, 4x. In the bottom row, my leading term here is a negative 9, so we want to divide out that negative just like we did, where was it, around here, or well, I should say right here, it was a negative 4, so we want to divide out a negative. Same thing down here, so it'll be a negative, and then the GCF between 9 and 3 would be 3. GCF going straight up, we're going to do that would be what, 3, and then an x as well, and then going up this way was the 1, but we got to make it negative because that outside number here is negative. Now if this number here is negative, we don't have to do negative with that. You're just looking at this number. If this is negative, this one's going to be negative. If this is negative, this one's going to be negative. So just keep that in mind. And then you have your two answers, put them there. 4x minus 3, which was the same thing here, and then 3x minus 1, same thing there. Okay, last but not least, do one more. So again, my leading term is 5, so I'm going to have to take 5 multiplied by a negative 24. So 5 times negative 24 is going to be 120. So 5 times negative 24 is going to be negative 120. Find all my factors of that. eventually you're going to come across 8 and negative 15. 8 times negative 15 would be a negative 120, and then when you add them together, they're going to be that negative 7 that you would want. So I'm going to bring down my 5x squared, and my 8x is going to be added in there. I'm also going to add in that negative 15x, and then bring down my constant. I'm going to apply my parentheses, and then I'm going to do the GCF again. So the GCF between 5 and 8 is just going to be an x, right? The biggest common factor between 5 and 8 is just 1, so we could divide out that x. And then my leftover is going to be a 5x plus 8, just taking out that x. And then again, we have a situation here where my leading term is negative, so I'm going to take out a negative here. And then the GCF between 15 and negative 24 or minus 24 is going to be negative 3, I believe. And we don't have to take out an x. We'll do negative 5 divided by negative 3 is going to be a positive 5 with an x. And then negative 24 or minus 24, if we're dividing out a negative, it's going to be plus 8. And then again, just to confirm, this one and this one is the same. So now we could take x and then subtract 3. That's going to be my first binomial. And then followed by the common binomial, 5x plus 8. Okay, I'll show you one last thing here. We'll do the box method. I'll add in my beginning term, my last term, my constant. We would multiply them together to see we get negative 120. Then we come up with all the different factors of negative 120, 8 and negative 15 would be what we wanted. Then we plug them in there and there with an x, and then we do the GCF. I'll even do some arrows here. GCF going to the left, so that's going to be a 5x, and then the GCF down below would be plus 8x. So in this case, we have a positive here, so you just keep it as positive. We could do plus 8. But up here, we know it's going to be a negative in this area because that outside term is negative, and if that happens, we always want it to be minus. So I'm going to do maybe some arrows going straight up, so GCF going up that way. So then my value is just going to be x, and then up here it's going to be minus 3. The greatest common factor between 15 and 24 is going to be 3, and then, like I just said, it's going to be negative because that 15 is negative. So there we have it. We've got the 5x plus 8, which matches it here. X minus 3, it matches there. And that is the last of the 3 factoring problems.